Dear students, in this section, let us discuss about dimensional analysis. This analysis will be more useful when you want to converge the number of variables affecting on a particular performance. In this sense, I may take a particular example and will try to solve a problem so that we can understand more with more clarity. Okay, so let us assume there's a flight which is going to travel at a supersonic speed. Okay, let us going to assume there's a flight which is going to travel at supersonic speed. So you know what is supersonic when the Mach number is going to be greater than 1. Okay, so let me have the Mach number of the flight is 2 or 3. So it is called supersonic. Now when this flight is moving like this, there will be resistance of force will be offered to the flight because of the air drag. That resistance force is given by R. Now we know what are the variables which will influence this resistance. So the resistance to this flight will be affected by a number of variables. Say it depends upon the length. If the length is more, then the resistance through which the air will be passing over the entire flight length will be more. So the resistance will be more when your length of the flight is more. Okay, then it depends upon the velocity at which it travels. If it travels at a lesser velocity, what will be the resistance force? What will be the resistance force when the velocity is going to be higher? So it depends upon the velocity of the flight also. It also depends upon the air density, because when you are going to have the flight which is going to fly at 40,000 feet high, this density will be relatively lesser. Which density? The air density will be relatively lesser at that altitude. So it depends upon the resistance force depends upon the density of air, as well as the viscosity of air, mu, as well as it depends upon the bulk modulus K. So this term is called as what? Bulk modulus. So now in the problem, they will define that when a flight is flying at supersonic speed, the resistance offered to this flight depends upon various parameters, namely the length of the flight, the velocity at which the flight travels, the density of the air, the viscosity of the air, as well as the bulk modulus of the air. So they will give a relationship like this. Now it's very difficult to consider which parameter which has been more influenced for the resistance offered to the flight. So we are unable to come to some common decision. So which will have more influence, whether length or mu or rho. So instead of that, if I am going to have a combined parameter like non-dimensional numbers like Reynolds number, Nusselt number, Prandtl number, Froude number, Grashof number, I can tell what will happen if the Reynolds number is increased, whether the resistance force will increase or decrease. Okay. Similarly, if I am going to have other non-dimensional number, what will be the influence of this number on the resistance force? So we are trying to actually arrive at some non-dimensional numbers which will give a qualitative idea for the particular parameter which you want to optimize. Here the parameter what you want to optimize is nothing but the resistance offered to the flight when it is flying at supersonic speed. So in that case, we came to know the resistance offered to the flight is influenced by many parameters like this, many variables like this. But here the number of variables are more, and I'm unable to give more clear prediction for this effect of resistance, effect of these parameters on this resistance force. Instead of this number of variables, if I am going to have some two non-dimensional numbers, then I can easily tell how the resistance force of the flight will be affected by these non-dimensional numbers. That is what we are going to do further. On continuing further, we see that the resistance force offered to the flight depends upon these variables. Otherwise, we can also write, I will write like this. Now, R is a function of these parameters, which means it can be, say, 2L squared minus 3V cube plus rho into, okay, plus rho cube, some variables, minus 2 mu plus k. So now we can see this is called as the function. This function I have written on my own. This is not right. I have written this function. Now R depends upon length, velocity, density, mu and k. This function I have written on my own. Okay. Now R is called as the dependent variable, and the terms which are on the right hand side are called as the independent variable, namely the length, velocity, density, mu and k. They are known as the dependent variables, and this is called the independent variable. On the other hand, now I can even take this r on the right hand side. So it becomes what? 2l squared. So now you can see this r is a function of what? L, V, rho, mu, k. Now what I'm going to do means I'm going to take even the r to the other side. So it becomes what? 2l squared minus 3v cube plus rho cube minus 2 mu plus k minus r equal to 0. Now this become another function. Now I can tell this become what? Another function. Now let us call that function as phi. If you are not happy with phi, you can call even as f dash. What are the function you want to call? So now this phi is a function of what? L, V, rho, mu, k as well as r is equal to 0. So if we have a function r as a function of these variables, then I can write another function, say phi, which will be a function of, phi will be a function of what? Function of L, R, V, rho, mu and k. This function will be equal to what? This function value will be equal to 0. And this function is called as what? Now phi of this function can be called as with another name. Let us say that function is phi, because the phi depends upon the various variables, including the dependent variable. I hope it's clear. So in this case, now we have written now phi of this r, small l or capital L, where L is the length of the flight, then velocity of the flight, then the viscosity mu, then rho is nothing but the density, and k is nothing but the bulk modulus, is equal to what? 0. So here the number of variables, that is the total number of variables, whether dependent or independent, it is called as what? 1, 2, 3, 4, 5, 6. So I can call this as what? Total number of variables. Now there are basic variables. What are these basic variables means? They are nothing but mass, length and time. Mass, length and time. So this total number of variables generally called as n, and basic variables are called small m, which are generally 3. They are nothing but what? Mass, length and time. So m equal to 3. If there is a temperature also, then the basic variable will be 4, but generally in fluid mechanics at this stage we will restrict m equal to 3 alone. We are not considering the temperature. We are considering only the fluid flow. Okay. So if in case if temperature is given, then I have to include theta also. Then my m will be equal to what? 4. But most of the cases we are not considering this theta, and hence m equal to 3. So in the problem, if there is no indication of the temperature, there is enough to go with these 3 parameters. But whenever there is a heat transfer and there is a temperature involved, definitely you have to consider m equal to 4 rather than 3. So that you have to take into your mind. Okay, fine. So this is m. Now what is the meaning of finding n and m? The usage of finding n and m is that I am going to find the number of pi terms. So this number of pi terms is given by n minus m. N minus m is nothing but 6 minus 3 is nothing but 3. 6 minus 3 is what? 3. So here we are trying to do the dimensional analysis by a method called as Buckingham's Pi Theorem. Buckingham's, because this is the person who discovered this theorem, and hence it's called as what? Buckingham's Pi Theorem. So here he tries to form number of pi terms. The number of pi terms in this case will be equal to 3, because we had the formula for finding the number of pi terms equal to n minus m, where n is the total number of variables including the dependent and independent variable, and m is the basic quantities. Okay, here it doesn't involve the temperature, so m equal to 3. So we found the number of terms will be 3, which means I have 3 pi terms, which means I have pi 1, pi 2 and pi 3. So I have to form 3 pi terms, namely pi 1, pi 2 and pi 3. Let us continue further how to determine this pi 1, pi 2 and pi 3. So now we are about to form 3 pi terms, namely pi 1, pi 2 and pi 3. For this we want to choose the repeating variables. We want to choose what is called as what? repeating variables. The first condition for the repeating variable that it should not be the dependent variable. I'll repeat once again. For determining the repeating variables, it should not be the dependent variable. In this case, which is the dependent variable? The resistance offered to the flight, or is the dependent variable. At most, we should have to take care that this should not be the repeating variable. At most, we have to take care that the dependent variable should not be the repeating variable. In this case, are the dependent variable, so we have to avoid that as the repeating variable. Then how to choose the repeating variables? Repeating variables should be chosen based on geometrical variable or property. The second is the flow property. The third one is nothing but the fluid property. So we have to give importance to each one of these to form the repeating variables. So the number of repeating variables should be 3. Out of these 3 variables, it should not be dependent variable. That is the first condition. The second condition is that it should be one of the terms should be the geometrical variable. One should be flow property, another should be the fluid property. Out of these things, first this R is ruled out because this is a dependent variable. Now let us come to the length. Length is nothing but the geometry. What are other geometry properties? You know, area, diameter, perimeter, volume. So these are related to what? Surface area. These are related to the geometrical parameter. So there is called as geometric parameter. So length is also what? A geometrical property. Length is what? Geometrical property. What about velocity? What about the velocity? The velocity is nothing but the flow property. Velocity, discharge. They are nothing but called as what? Flow. The rate at which the fluid flows. The speed at which the fluid flows. So it's nothing but the flow property. It's nothing but the flow property. So I'll call this as what? FLO. Flow property. What about mu? Mu for air is different. Mu for oil is different. Mu for water is different. So mu means what? It's a fluid property. Mu is nothing but a fluid property. Similarly, what is rho? Density. Density is also a fluid property. Density is also a fluid property. For air, the density is nearly 1.14 kilogram per meter cube. Whereas for water, it is nearly 1000 kilogram per meter cube at standard temperature. Okay, so we can tell this rho is also a fluid property. Then coming to the bulk modulus. What is meant by bulk modulus? The bulk modulus already we had defined is nothing but delta P by minus delta V by V. Or we can take this minus sign to the numerator. So it's delta P by delta V by V. That is, if I am going to apply some pressure, what is the corresponding change in volume to the original volume? I will repeat what is bulk modulus. Bulk modulus is nothing but a term. If I am going to change a pressure to a particular system, what is the corresponding change in volume to its original pressure, to its original volume? So we can see delta V by V becomes unitless because the ratio meter cube by meter cube will go without any unit. So what is the unit of delta P? Delta P is nothing but force per area. So the unit of K will be Newton per meter squared. As that of delta P. What is delta P? Newton per meter squared. Got the logic? So the unit of this one is nothing but what? Newton per meter squared. The unit of bulk modulus is nothing but Newton per meter squared. One more thing is, now we want to know whether bulk modulus is a flow property or a geometrical property or a fluid property. Can anyone tell what is this K? Yeah, you are right. K is also once again a fluid property. K is also what? Once again a fluid property. So first of all, you should be in a position to identify or to classify the given terms as dependent variable, geometrical variable, then flow properties or flow variable, then fluid properties. It may not be the same order. In this case, we got it the same order, but it need not to be the same order. Okay, it can be in the other way also. Okay, fine. Now let us try to form the pi terms with these repeating variables. So now the first term should be geometry. So here the only one geometry variable is available. So I will put as L. I will put as what? L. Now coming to the flow property. How many flow properties are there? There is also only one. So there is no other way. I will put only V. Coming to the fluid property. How many fluid properties are there? Mu, rho, as well as K. All are what? All are fluid properties only. But I can give chance to only one variable. Here I will give the chance to density. You may ask a question, what shall, if I have taken mu? Nothing wrong, you take it. Some of the students may take mu as the repeating variable and you can solve it. Some of the students may take K as the repeating variable and solve it. So there's nothing to worry. Out of these three variables, mu, rho and K, all are fluid properties. You have the rights. You have the liberty to choose any variable, but I have taken rho. Because rho is considered the basic property of a fluid, so I have taken rho. Got the logic? How we have chosen the repeating variables? The reason for choosing the repeating variables should be geometry, flow, and fluid property. I hope you got it. Now, what you have to do means, here also you have to write LV rho. Here also you have to write LV rho. Now you might got what is the meaning of repeating variables. That these variables are repeating in all the pi terms, namely pi 1, pi 2 and pi 3. So what about the other three terms? So now L is over, V is over, rho is over. Now what are the other terms? Rho, R, mu and K. So we can write this R, mu and K. So we have formed the three pi terms. I will repeat once again. Once you made the repeating variables, then you have to see what are the remaining variables. R, mu and K. So you can write R, mu and K. You can also write in any order. First you can write as mu. Second you can write as R. Third you can write as K. So there's no particular things you have to follow. You can choose any other variables as what? The fourth variable. So this is the way how you have to form the pi terms. Now once you form the pi terms, now what you have to do means, you have to do you have to write like this. A1, B1, C1. Coming over here, A2, B2, C2. Coming over here it is A3, B3, C3. What is A1, B1, C1 means? They are nothing but the powers. They are the powers of the coefficients L, V and rho. I hope you got it. So since they are repeating, I am writing as A2, B2, C2, A3, B3, C3. Now I hope it is clear how to form the pi terms, namely the pi 1, pi 2 and pi 3. Once you form the pi terms, now only we are coming for the dimensional analysis. Now let us see what are the dimensions. First we will take length. What is symbol? L. What is this dimension? Dimension is nothing but length is L. What is its units? Unit is meter. Now let us come to velocity. What is velocity? Velocity is equal to distance traveled by time taken. Okay, this is a small v or capital V. We are following here capital V, so capital V. So the unit is meter per second. Distance traveled by time taken or displacement by time. Displacement by time. So it is meter per second. Meter means length. Time means by t. So how we can write L by t means we can write either L by t or we can write L t power minus 1. Both are same. How I am writing this one? Based on the units. So it's always better. It's not better. You should know the units of each and every variable involved in this particular equations. Okay. So we know the unit of velocity is meter per second. So it is length by time. So it's nothing but L t power minus 1. Okay. Now let us come to density. Rho is nothing but density. What is the unit of density? Mass by volume. Mass is kg. Volume is what? Meter cube. So what is mass? Mass is nothing but m. Mass is m. What is meter cube? Is a length into breadth into height. So L cube. Length is L. Breadth is another L. Width is another L. So L into L into L. So it's L cube. So what are the unit? We can write either you can write like this or we can write as what? M L power minus 3. So this is the dimensions for density. This is the unit of density. This is the quantity. If you want, you can write this as what? Your quantity. Now let us now proceed for resistance. What is resistance? Can anyone tell what is meant by resistance? Resistance is nothing but a force. A negative force which opposes the motion. There is nothing but what? Resistance. So the unit of resistance is what? The unit of force only. It's nothing but the unit of force. So it's nothing but Newton. It's nothing but what? Newton. When I am telling Newton, we are unable to understand. So what is force? The unit of force is Newton. So this unit is Newton. Okay, what is m? The unit of m is kilogram. What is the unit of acceleration? Meter per second squared. So I can write either Newton, or if I am going to expand this Newton, this is nothing but what? Kilogram meter per second squared. So what is kilogram? Mass. What is meter? Length. What is second squared? Time squared. So the value of r is nothing but ml t power minus 2. ml t power minus 2. I hope you got it. How we arrived at the dimension of the force or the resistance force is nothing but what? Newton. Newton is nothing but what? Kg meter per second squared. So it's ml t power minus 2. Coming to the last one. The last one is what? Before going to the last one, we will have mu also. So we have two more. So let us say k. What is k? Already I told the unit of k is, just now we discussed this, Newton per meter squared. What is Newton? Newton has already we have seen here now. So Newton is nothing but kg meter per second squared into meter squared. So 1 meter can cancel. So it will be mass by time squared into L. So the unit the dimensions of K will be what? M L power minus 1 T power minus 2. So when this L is taken to the numerator become minus 1, then T squared is taken to the numerator become T power minus 2. So if we want to write the unit also, you can write the unit will be kg into divided by second squared meter. So this is the unit of your K or the pressure. So only one more term which is left out is your mu. You have to find the value of mu. Okay, we'll do that also. So how to find the dimensions of mu? What is mu? Mu is nothing but coefficient of dynamic viscosity. Mu is nothing but what? Coefficient of dynamic viscosity. We should know the Newton's law of viscosity. This tau equal to what? Mu into du by dy is called as Newton's law of viscosity. Here tau is the shear stress. So it's force per area. D is nothing but velocity. dy is nothing but what? Distance. From this we will be able to obtain the unit of mu. We will be able to obtain the unit of mu. From the value of mu, we can from the unit of mu, we can arrive at the dimensions of mu. We will do it. Okay. So this du by dy is called as velocity gradient, or it is also called as rate of shear strain. This tau is nothing but the shear stress. So the shear stress is directly proportional to the shear strain, and any fluid which obeys these laws is called as what? Newton's law of viscosity, or Newtonian fluid, or the fluid is called as what? Newtonian fluid. Okay. So here mu will be equal to what? Tau into dy by du. What is tau? Shear stress. Stress is nothing but once again Newton per meter squared. Newton per meter squared. What is dy? It is meter. What is du? It is meter per second. So that second will be here. Yeah, let us put like this. So now what is Newton once again? Newton is once again kilogram meter per second squared. So I'll take that help. So Newton is nothing but kilogram meter per second squared into meter squared into meter per second. So this meter squared get cancelled. This 1 second get cancelled. So the answer will be kg. Further continuing, we got the value of dimension of mu as kg per meter second, which is nothing but mass by length into time. Because mass is nothing but, this meter is nothing but your length and time is t. So what is the dimension of now your mu? It's nothing but m L power minus 1 T power minus 1. So what is the unit of this one? The unit will be kg per meter second. So students, you should be in a position to derive or to arrive at the units of all the variables involved in the given equation, as well as from the units you should be in a position to convert them into the dimensional form, and hence this analysis is called as dimensional analysis. And hence this analysis is called as what? Dimensional analysis. Any doubt up to here? Any doubts you have? We are trying to form the pi terms. Why we found only 3 pi terms? Because the total number of variables is 6 and the number of basic quantities are 3. So n minus m is nothing but 6 minus 3 equal to 3. So we want to form 3 pi terms. What are the rules for forming the pi terms? We should first of all form the repeating variables. What are the condition for the repeating variables? It should not be repeating. Okay. The condition for the repeating variable should not be a dependent variable. Okay. So here we are violating the R. Then we are trying to give importance to the geometrical variable, flow variable and fluid property. So these 3 terms are repeating all the equations. So they are called as repeating variables, and we are giving the coefficients to the power as A1, B1, C1. Similarly, A2, B2, C2 and A3, B3, C3. The remaining, there are 3 variables. You write those variables here. So until now, I hope it is clear how to form the pi terms. Let us proceed further to get the values of this A1, B1, C1 by the dimensional analysis. Okay. So it's better to write the values. So it is, even we can write the L as m power 0, L power 1, T power 0. Because why? Anything power 0 is 1. Anything power 0 is 1. So 1 into L power 1 is L. So the answer is L. So either you can write L as L, or you can write as L as what? M power 0, L power 1, T power 0. I hope you know the reason now. Okay. Now what is the, this is LT minus 1, which means what? LT minus 1 can be written as m power 0, L power 1, T power minus 1. Similarly, what is m by L cube? m by L cube can be written as what? M power 1, L power minus 3, T power 0, because there is no time involved. So this is nothing but your M, L power minus 3 for your density. Coming to the, which one? The resistance, it is ml T power minus 2. ml T power minus 2. So we can write this ml T power minus 2 as m power 1, L power minus 1, T power minus 2. Okay. Then coming to, I'm sorry, it is kgm. So L should be positive. So it is m power 1, L power 1, T power minus 2. With the units we can write easily. Now it is nothing but m, L power minus 1, T minus 1. So it's absolutely right, because it will be what? M power 1, L power minus 1, T power minus 1. Along with that we will add a viscosity also. So the viscosity will be what? M power 1, L power minus 1, T power minus 1. Because I hope, otherwise it is kg per meter second, isn't it? Kg per meter second. So it's right only. Yeah. So it is nothing but kg per meter second. So we will take the first pi term and derive the formula. Okay, so pi 1 is equal to L V rho R. L raised to the power of A1, V raised to the power of B1, rho is C1. So what are the dimensions for pi? Pi is a constant which is unitless, and hence the dimensions also there is no dimension, which means it is nothing but m power 0, L power 0, T power 0. Why? Because anything is there is no unit for this one. Okay, so there is no dimensions for this pi term because it's a constant. Okay, now let us come to length. Length is nothing but what? M power 0, L power 1, T power 0 whole raised to the power of A1. Then what about V? V is nothing but what? M power 0, L power 1, T power minus 1, okay, whole power B1. Let me erase this length quantity. This one I will erase it. Now coming to the rho. Rho is nothing but this one. So it is m power 1, L power minus 3, T power 0 of C1. What is the unit of resistance? The resistance is this one. So it is m power 1, L power 1, T power minus 2. I will repeat. First I am forming this equation pi 1 equal to L power A1, V power B1, rho power C1 and R. Now just I am trying to substitute the values of the dimensions. We have the dimensions for L, V and rho as well as R. So just write here. But we don't have the dimensions for pi because it's a constant. So you simply write as what? M power 0 because that is 1. L power 0 is also 1. T power 0 is also 1. Now what we are going to do means we are going to compare the coefficients. We are going to compare the power coefficients and we are going to try to get the values of A1, B1, C1. So now comparing the powers of m dimension. So the left hand side is what? M power, the thing is 0. So the left hand is 0. Here it is what? 0 into A1. So there is no need to write 0 into A1, but simply I am writing. Is nothing but 0 only. Plus 0 into B1. That's also nothing, there is no need to write, but simply I am writing. The next step I will not write. Okay, here is 1 into C1. So it is 1 into C1 is nothing but C1. Here it is plus 1. This one is what? Plus, only 1 is there. So it is 1. Now we can see 0 equal to, this is 0, this is also 0. So 0 plus 0 plus C1 plus 1. From this what we got? C1 plus 1 equal to 0, which means C1 equal to minus 1. So you can see that I arrived at the value of C1. I got one coefficient. I got the value of one coefficient, namely the C1. Any doubts so far how to find the value of the coefficients? Just you write the dimensions, then compare the coefficients of the powers. When I am comparing it with the m, I got the value of C1 as what? Minus 1. I hope you got it. Now proceeding similarly to this, I am going to compare the powers of, instead of m, I am going to consider the power of L. So plus let us make a note, C1 equal to what? Minus 1. So when I am going to compare the powers of 1, I will make it fast. Is 0 because L power is 0. It is 1 into A1. So 1 into A1 is A1. It is 1 into B1 is B1. It is minus 3 into C1. So it is minus 3 C1. I hope you will be able to understand. L power minus 3 is nothing but what? Minus 3 into C1 plus Here L is having a positive value of 1. So it's 1. So now what I'm going to do means it is A1 plus B1 minus 3C1 plus 1 equal to 0. But we know the value of C. What is the value of C? Minus 1. So A1 plus B1 minus 3 into minus 1 will become plus 3 plus 1 equal to 0, which means A1 plus B1 is equal to minus 4. Let us have this as equation number, some equation number. Let us have this equation number 2. Now I can't solve this equation because there are two unknowns in a single equation. So let us try to form another equation and try to solve them so that we can get the value of A1 and B1. So now we have another expression, A1 plus B1 equal to how much? Minus 4. Similarly, compare the coefficients of T. Compare the coefficients of what? T. I hope I can make it fast. So T power 0, 0. It is 0 A1. I won't write. It's 0 only. It is minus B1. I hope you got it. It is 0 into C1 is 0 only. This is what? Minus 2. So from this minus B1 equal to plus 2. B1 equal to, plus 2. So B1 will be equal to minus 2. So I got the value of B1 as what? B1 as minus 2. Now substitute the value of B1 equal to minus 2 in this equation. I'll get the value of A1. So let us try to find out. A1 plus B1 equal to minus 4. So A1 minus 2 equal to minus 4. A1 equal to minus 4 plus 2. So A will be equal to minus 2. A equal to what? Minus 2. So we got the value of A as minus 2, B as minus 2, C as minus 1. I hope you got it. A minus 2, B also minus 2, C is what? Minus 1. So once you find the value of A1, B1, C1, what do you have to do? Or what is the purpose of finding this A1, B1, C1? Once again you write in the same pi term. So pi term equal to L of A1 is what? Minus 2. What is B1? Minus 2. What is C1? C1 is minus 1 into R. So I formed the first equation, pi 1 equal to L of A1, then V of B1, then rho of C1 into R. Then I try to find the value of A1, B1, C1. Once I find by equating the power coefficients, once I found the value of A1, B1, C1, substitute over here. Then what is the thing? Now we can write pi 1 is nothing but R divided by rho. Why? This rho is minus 1, it's going to be, denominator become plus 1. So rho power plus 1. This is what? V power plus 2. This will become what? L squared. I hope you got it. So these terms which are negative, if I am going to take it to the denominator, they will become positive with the respective power terms. So we got the value of pi 1 now. We got the value of what? Pi 1. The beauty of this pi 1 is that it will be non-dimensional. It will be what? Non-dimensional, because the unit will be both will be same. Both will be newtons. So there is no unit. So our aim is to develop some non-dimensional numbers so that we can converge the number of variables. Here there are 5 variables where the resistance to the flight depends upon. But we want to simplify and give us 2 variables. So it will be 2 numbers, 2 non-dimensional groups or 2 non-dimensional numbers which will be easy for us to analyze. That is the main aim. We will proceed further. Let us now continue further to determine the value of pi 2, the second pi term. So once again the formula is pi 2 equal to L power A2, V power B2 and rho power C2. With the second variable is mu. The first variable we have taken as R, the second one we are taking as mu, and for the third pi term we will take as K. Now as usual I have written the dimensions for pi, which is a constant. So m power 0, L power 0, T power 0. Similarly for length we have written, for velocity and rho as well as the mu. We know the dimensions of mu as what? M power 1, L power minus 1, T power minus 1. Now comparing the coefficients for m, I will get 0 equal to 0 A2 plus 0 B2 plus C2. This is what? Plus C2. Minus 1. Not minus 1, plus 1 equal to 0. From this C2 equal to minus 1. From this C2 equal to what? Minus 1. Now let us compare the coefficients of L. This is based on m. Now let us compare the coefficients of L. So the left hand side is 0. The right hand side will become A2. Here it will become plus B2. Minus 3C2. This is minus 1. So what is C2? C2 equal to minus 1. Okay, so minus 1 will become plus 3. Minus 1 will become plus 2. So A2 plus B2 will become minus 2. So plus 2 when you are taking to the other side become minus 2. This is one expression. Okay, let us move further. Now let us compare the coefficients of T. It is 0. Here also it is 0. Here also it is minus B2. minus B2. Here it is 0, here it is minus 1. So B2 is equal to minus 1. I am taking the B2 this side, so it will be B2 equal to what? Minus 1. Now you try to substitute the value of B2 in this equation, I will get A2. So A2 minus 1 equal to minus 2. So A2 is equal to minus 2 plus 1. So A2 will be equal to minus 1. B2 equal to minus 1. So it is A2 minus 1 equal to minus 2. So we are going to take, I hope it's right. So A2 equal to minus 1. Let us continue further and let us try to find the pi 3 term. So it is m power 0, L power 0, T power 0. It is m power 0, L power 1, T power 0 of A3. It is m power 0, L power 1, T power minus 1 of B3. It is m power 1, L power minus 3, T power 0 of C3, and the dimensions of K, bulk modulus, is nothing but m, L power minus 1 and T power minus 2. It is similar to that of the pressure. K is nothing but stress, so it's nothing but what? Bulk pressure is nothing but Newton per meter squared. So from that we arrive this value. Now compare the coefficients of m. 0 is equal to this 0, this 0, this C3, that is 1. This is plus 1. So plus 1 equal to 0. So C3 equal to minus 1. Comparing the coefficients of L now, 0 is equal to A3 plus B3 minus 3C3 minus 1. So A3 plus B3 minus 3 into minus 1 is plus 3, minus 1 equal to 0. So A3 plus B3 is equal to minus 2. Now compare the coefficients of T. So 0 equal to 0 minus B3, this 0, this minus 2. So B3 equal to minus 2. B3 equal to what? Minus 2. Substitute this B3 over here. So A3 minus 2 equal to minus 2. So A3 will be equal to minus 2 plus 2. So A3 equal to 0. A3 equal to what? 0. So I got the value of A3 as 0, B3 as minus 2. So simply I will substitute here A3 as 0, B3 as minus 2 and C3 as minus 1. That's it. So this is nothing but my pi 3 term. So what is now the pi 3 term? Pi 3 term, this is anything for 0 is 1. So it's k by rho v squared. K by rho v squared. Let us tell what is pi 2. Let us say what is pi 1. Okay. Because we have already derived it, we will continue further. Let us continue with the session. We got the value of pi 1, pi 2, pi 3. But the solution is, it is like this. Pi 1, pi 2, pi 3 equal to 0. Which means R by rho L squared V squared, comma, mu by rho VL, comma, K by rho V squared is equal to 0. So this is the final solution. We are writing in this form, but it's also better to write in another form like this. R by rho L squared V squared is a function of mu by rho VL, comma, K by rho V squared. So this is we are almost approaching the solution. So let us try to define what about this value and what about this value. They are non-dimensional. They don't have any units. But let us try to find what is this one. We know that Reynolds number is given by what? Rho VD by mu. So now we can say it is nothing but what? It is nothing but mu by rho V L. Instead of D we have L. D is also having a unit of meter and L has a unit also of meter. This is a hydraulic diameter. So the characteristic length both are same. So which means now we have mu by rho VL, which is nothing but 1 by RE. Either you can write as 1 by RE or you can even write RE, because instead of phi as a function, I will take another function as phi dash. Then the function will become what? The reciprocal of the your Reynolds number. So it can become Reynolds number also. There's no much difference between 1 by Reynolds number and Reynolds number, because I can change the writing of a function in terms of Reynolds number. So right as of now, this term is about what? 1 by Reynolds number. So what about this term? This term is very critical. We know A is given by root of K by rho. What is A? A is nothing but velocity of sound in air. Velocity of sound in air is nothing but what? A. So it is nothing but bulk modulus by rho. So what will be A squared? A squared will be K by rho. What is this K by rho then? So I can write this K by rho V squared as A squared by V squared. So we have know another term, namely called as the Mach number, which is nothing but Mach number is given by C by A. Already we have explained this concept in compressibility and Mach number session. So the Mach number is given by C by A. What is C? The velocity of the fluid or the velocity of the flight. By A is what? Velocity of sound in air. So this non-dimensional number is nothing but Mach number. So what will be here now the C is similar to your V. Velocity of the, here in this expression they are given the velocity of the flight as V. So V and C are once again the same. So this number is nothing but what? 1 by Mach number squared. 1 by Mach number squared, because it is C by A, it is what? A by C. As well as the square term. So now this term becomes what? 1 by Mach number squared. So this is nothing but what? Rho R by rho L squared V squared. Now what is the intention of deriving this expression is that we try to convert this frictional resistance offered on the flight as a parameter of two non-dimensional numbers, namely the Reynolds number and the Mach number. If you want, I can write still this as what? R by rho L squared V squared is instead of phi, I can put as what? Phi dash of what? Instead of 1 by RE, I can put as RE comma Mach number squared. Got it? This function I am writing is another function because it is only a reciprocal. So phi dash of RE comma Mach number squared. So finally what we are trying to do in this work is that initially the frictional resistance depends upon 5 variables, namely the density, the length, the velocity, the viscosity of the air, the bulk modulus of the air. So it's very difficult to study each and every parameter individually. Now it becomes very easy. If you want to study about the frictional resistance, it's enough to study the effect of Reynolds number and the Mach number on the resistance of the resistance offered on the flight. Got the logic? So that's what I told you earlier. If there are a number of independent variables, it will be very difficult to optimize this parameter in order to arrive at the optimal value for the given parameter. The given parameter here is the resistance offered to the resistance offered on the flight when it's traveling at supersonic speed. So there is no need to now do experiments related to density, related to length, related to velocity, related to mu, related to k. That's the bulk modulus. Instead of that, it is enough to do the analysis by varying only the Reynolds number and Mach number, and Reynolds number and Mach number, I hope. So now it's enough to just plot a graph. Now, now it's enough to plot a graph between Reynolds number and resistance. It is enough to plot a graph between Reynolds Mach number and what? The resistance. If you are not happy with the resistance, you can even plot what? R by rho L squared V squared. Why? This also become non-dimensional, this also become what? Non-dimensional. So this graph will tell me at what value of my Reynolds number my resistance will be lesser or optimal one. Similarly, at what value of my Mach number squared, my value of R by rho squared L squared V squared will be optimal. That is optimal means the minimal here. Optimal means here is minimal. So now if you are going up to this stage only, actually you can enjoy the benefit of the dimensional analysis or Buckingham Pi theorem. If I go to simply derive some formula and derive some equation, simply like pi 1, pi 2, pi 3 equal to 0, you do not know why you are doing. We will be simply doing because we want to derive something. But our aim is that I am trying to convert the dependent variable in terms of 5 variables. Now I made us in terms of 2 non-dimensional numbers, namely in this case it is Reynolds number and Mach number. So if I am able to draw the plot between these two things, I will be able to obtain the value of R directly. So this gives an a very direct method of converging of various variables to arrive at the optimal solution. I hope you enjoyed the concept behind this Buckingham Pi theorem and what is the usage of the formation of the non-dimensional numbers. Thank you.